let's do negative angles. Right, let's start off by saying sine of negative theta. That is negative sine theta, because that's below 0 degrees on the right hand side, below the x-axis, moving towards 270 degrees. In the fourth quadrant that would be, and in the fourth quadrant sine is negative. Cos of that same angle is positive, because in the fourth quadrant cos is positive, and tan would be negative because tan is negative in the fourth quadrant. Now, take very good note of this. Anything below 0 degrees is negative theta, and anything above 0 degrees is positive theta. We have the cast system there, with quadrant 1 being at A, 2 at S, 3 at T, and 4 at C. So there we go. Right, cos is always going to be positive in that fourth quadrant. The other two are always going to be negative though. So just remember, if you've got sine of a negative angle, it's in the fourth quadrant. Tan of negative, and so is cos negative in the fourth quadrant. However, cos is always positive in the fourth quadrant. So that negative angle turns into a positive one for cos. Take good note of that. It's very important to remember, that you don't get confused. Now, if you had a negative angle that would be greater than 90 degrees, it would now be sitting in the third quadrant. So just make note, you'll have to add 360 degrees or add 180 degrees. Let's do our special angles. Right, let's move on to our triangles. Our special triangles start off with drawing an equilateral triangle. It should look something like this. You've got 3 equal sides with 3 equal angles. The angles naturally add up to 180, so with 3 angles you divide that by 3, giving you 60 degrees for each angle. So there we go. At the top we write 60. What we then do is we cut that angle in half, making 30 degrees on each side. Right, each side length would give you a distance of 2 units. And now what we'll say is we say all equilateral angles are cut in the middle from the top downwards to its base. And that's how we get our 30 degrees. So all of our sides are equal to 2. Because we cut our base in half, we say our base is now equal to 1 on each side. And if we count 1, 2, 3, we then can write a square root of 3 for the upright. There's obviously a mathematical way to calculate this by Pythagoras. But if you can just remember 1, 2, 3 and just put that square root sign, you'll be good. Now let's draw a square. Every square has 4 90-degree angles that add up to 360 degrees. We then draw a diagonal across from bottom left to bottom right, cutting those angles in half, giving you 45 degrees for each one, and leaving you with a 90 degree at the bottom right. This is a unit square, so each side length is equal to 1, except for when you cut in half, you then go 1, 1, and then for the long hypotenuse, you'll write a square root of 2. So if you can remember that from the equilateral, you've got 1, 2, 3, and just put the square root sign over the 3. And then for the square, you cut the square in half, and you've got equal lengths of 1. You have 2 sides that are equal to 1, with 2 45-degree angles, and a square root of 2 for the hypotenuse. So just go 1, 2, and then put the square root over the 2. So as I said earlier, just to make a note about it, you cut your square diagonally, and you make a 45-degree isosceles triangle. Take good note of that. It's going to help you a lot in the future. Here we go. We're going to draw out our box. Just remember your sine, cos, and tan rules. So it's SOHCAHTOA. And then we put our angles down for 30 degrees, 45, and 60 degrees, as well as also a 0 degree. Okay, just breaking this up so it's equal. There we go. Right, let's write 0 degrees, 30, 45, 60, and then your 90-degree angle. We'll start off by saying cos, sine, and then we'll write the tan. So, if you plug this into your calculator, cos of 0 will get you the answer 1. I'm going to break these up. So these are two that you specifically need to remember. If you don't have a calculator or if you're not allowed, cos of 60 degrees is a half, sine of 30 degrees is a half, cos of 0 is 1, tan of 45 is 1, and sine of 90 is 1. We then fill in our zeros. So our cos of 90 is 0, sine of 0 is 0, and tan of 0 is also 0. Through trig, we can easily calculate that cos of 30 is square root of 3 over 2 by doing adjacent over hypotenuse. Cos of 45 is 1 over root 2, sine of 45 is 1 over root 2, and sine of 60 is root 3 over 2. We then have tan, which is tan of 30 is 1 over root 3, and tan of 60 is root 3. Tan of 90, however, is actually undefined. You'll find out later on when we do graphic representation of trig that the tan of 90 is actually an asymptote. So take good note of this. At this stage, you'll still be allowed to use a calculator. However, if you take mathematics to a higher level for the likes of engineering, then you'll no longer be allowed a calculator. So let's do the quotient identity. Let's start off by saying tan theta is equal to sine theta over cos theta. It's very actually important that you understand this so that you can apply it later on. Now cos theta can obviously not equal 0 because it's in the denominator's position. So if it is the case, then you can just say that the tan of theta is undefined, meaning that the theta will be equal to what? 90 degrees, like we mentioned in that table before. So let's do the square identity. These are all just different methods to give you an understanding of different ways to get your special angles. So we now know that 1 is equal to sine squared theta plus cos squared theta. It's very important that you remember this because you're going to use this a lot when you manipulate your equations in trig. So, therefore, if we manipulate this equation and we take sine squared theta across or cos squared theta across, vice versa, we'll get this. So I've taken cos squared theta across, making it 1 minus cos squared theta is equal to the remaining, which is sine squared theta. And then I took the sine squared theta from the beginning, and I said 1 minus sine squared theta would leave me with cos squared theta on the right-hand side. So, sine theta is equal to plus or minus 1 minus cos squared theta. And cos theta is equal to plus or minus 1 minus sine squared theta. Another two very good identities to remember. That's it, easy game. We've got our angle alpha in blue and our 90 degree in red. We have sine, cos, and tan represented by y of r, x of r, and y of x. So we say shade your rear, cause x rays, tan your exterior. It's a very easy way to remember it because we'll definitely need to use this going forward. Make a very good note of that. So it's shade your rear, cause x rays, tan your exterior. You've got the shade part for sine, for y, and the r from your rear for the y of r. And you've got your cause before cos, x rays for x and r, and tan your rear with tan is y over r. So, with that said, let's look at the cos diagram. The C, A, S, and T that help you to understand where the angle is positive depending on whether it's a cos, a sine, or a tan. Right, so the sign of a trig ratio depends purely on its position on the Cartesian plane. All of the causes in the first quadrant, bottom right, was that the fourth one, bottom right, depends on how you call it. So you can call that top right hand side 1, then top left is 2, bottom left is 3, and bottom right is 4. Or you can start at the bottom right and start with it being 1, bottom right, 2, top right, 3, top left, and 4, bottom left. It all depends on you and your understanding. So I like to do it like this. I call that the quadrant 1. Quadrant 2 is top left, quadrant 3 is bottom left, and quadrant 3 is bottom right. It doesn't really matter what the quadrant number is as long as you understand the C, the A, the S, and the T. And I'll go into that now. So we start out by saying the x-axis starts at 0 degrees, then the y gets to 90, then we move in a anti-clockwise direction to 180 degrees when we meet the x again, and as we continue we hit 270 as we hit the y, and all the way back up to 360 when we meet the x again. With that said, let me explain the CA and S and T. So we start by saying all are positive in the first quadrant. We say sine is positive in the second quadrant. We say tan is positive in the third, and cos is positive in the fourth. Now if you start from cos, you go then to all sine and tan, you spell out the word cast.